Hey guys, it is Adam here. I hope you have a good day and you are ready to learn. Sorry if my voice sounds different. I adjusted my voice input settings. Also, I recommend that before solving this room with me, you check out my Linux Fundamentals Part 1 video, since this is already the second part and it builds on that. I'll be covering and explaining everything written in the room, so it's not mandatory, but it's recommended that you also read through the material as we go. With that said, let's check out task 1. So, this is where things start to feel a bit more real. Up until now, everything was happening inside the browser. Clean, controlled, no friction. In this part, we're stepping out of that comfort zone and moving into how Linux is actually used in the real world, remotely. That shift matters more than it sounds. In cybersecurity, you're almost never sitting directly on the machine you're working with. You're connecting into it, controlling it from somewhere else, and everything you do happens through that remote session. This room builds exactly that foundation. You're going to take the basics you already know and start extending them in ways that actually make them useful. Not just running commands, but modifying how they behave. Not just looking at files, but creating, moving, and managing them properly. And more importantly, understanding who is allowed to do what on a system, which is where things start getting security relevant. There's also a subtle jump here. You're not just observing anymore, you're interacting with the system more deliberately. Running commands, handling files, even executing scripts. That's where Linux starts turning from something you learn into something you actually use. If part 1 was about getting comfortable, this is where control starts to come in. And that's exactly what we'll build on next, when we connect to a machine the way it's actually done outside of a training environment. Task 2. Accessing your Linux machine using SSH. Meanwhile, I am yapping about SSH and cybersecurity. Let me just start the machines we are talking about. Instead of running commands locally or inside a browser sandbox, what we're about to do now is connect to an entirely different machine and control it as if we were sitting in front of it. That's a core skill in pretty much every area of cybersecurity. The way we do that is with something called SSH, Secure Shell. At a high level, it's just a protocol that lets you send commands to another machine over a network. But the important part is this. Everything you type gets encrypted before it travels, and only gets decrypted when it reaches the target machine. So even if someone is watching the traffic, they don't see your commands or credentials in plain text. Now in this task, you'll be working with two machines, your target Linux machine and the attack box, which is basically your control station in the cloud. Think of the attack box as your laptop, and the target as a remote server you're connecting into. Once both machines are running, you'll see an IP address for your target. That IP is the only thing you really need to reach it. I skipped a little time meanwhile, so we do not have to wait for the machines to be up and running. You are welcome. I just saved 10 seconds of your time, and also lost like 10 seconds explaining myself for no real reason. So, the SSH command itself is very straightforward. SSH, username, and the IP. Here, you're logging in as the user tryhackme, so your command will look like SSH, tryhackme, and the machine IP. So let's go and copy this, and then move all the way to the top for our machine IP, which we just got, and paste it to our terminal too. When you run this, two things happen. First, the system asks if you trust the host. This is normal. It's SSH making sure you're aware you're connecting to a new machine. You accept it, so just write yes as it asks. Then it asks for the password. Remember, it was tryhackme2 as your username. And here's something that catches a lot of people off guard the first time. When you type the password, nothing shows up. No stars, no dots, nothing. It feels like it's broken. It's not. It's still reading your input, just not displaying it. So you type the password, press enter, and if everything is correct, you're in. At that point, you're no longer working on your own environment. Every command you run is now executing on the remote Linux machine. That distinction is important. If something behaves differently than expected, it's often because you're not on your own system anymore. And this is exactly how real-world access works, whether you're managing servers, doing incident response, or moving through a network during a test. From here on, you're operating remotely. Let's clear our terminal with the clear command and jump to our next task, Introduction to Flags and Switches. Most commands you've used so far probably felt pretty simple. You run them and they do one thing. But in reality, almost every Linux command has way more control hidden behind it. You just haven't been using it yet. That's where flags and switches come in. Pretty much the same thing. I hear people refer to it either way. Think of them as modifiers. They don't change the command itself, they change how it behaves. A clean example is ls. By default, ls just shows you what's in the current directory. Nothing fancy. But the moment you add a flag like a, you're telling it, don't hide anything. So suddenly, files that start with a dot, which are normally hidden, show up. That's not a different command. Same command, different behavior. And this is where a common mistake happens. People memorize commands but ignore flags. That works at the beginning, but later it becomes a limitation. Right, because most of the real power comes from combining commands with the right options. Now, obviously, you're not expected to memorize every flag for every command. That would be painful. Instead, Linux gives you built-in documentation. If you run ls help, you'll get a quick overview of what the command can do. It's not meant to be pretty. It's meant to be fast. But if you want the full breakdown, that's where the manual pages can be handy. You can open them with man ls. This gives you a much more detailed view, descriptions, options, usage patterns. Now here's something practical. When you open a man page, it doesn't behave like a normal output. It's more like a viewer. You scroll with your keyboard, typically using arrow keys or space, and you exit with Q. That small detail trips people up more often than you'd think. They open it, and then get stuck inside it. Once you get used to it though, this becomes one of the most useful tools you have, especially when you're working with commands you've never seen before. Instead of guessing, you just check the manual and move forward with confidence. And this idea, modifying behavior instead of replacing commands, is something you'll keep using constantly as things get more advanced. Alrighty, let's check out our questions, shall we? Yeah, we already explored the man page of ls. What directional arrow key would we use to navigate down the manual page? Well, of course, the down arrow, as I were talking about it. Next question. What flag would we use to display the output in a human-readable way? Well, for this, let's go back to our man ls page and let's look it up. A little tip, meanwhile, it is usually, so not always, the first letter, which gives out the flag or switch's name. So yeah, it was indeed the first letter this time. Okay, let's go with our next task. File system interaction continued. Up until now, you've mostly been looking at the file system, listing things, navigating around, figuring out what's there. Now you actually start manipulating it. At the beginning, you can see the commands we learned in part 1, so you should be familiar with them. Now Linux becomes practical, because these are the exact operations you'll use constantly, what we're about to see. Whether you're analyzing a system, moving files during an engagement, or just organizing your workflow. Let's start simple with the touch and make directory commands. First, I use the ls command, so you see what's there at the moment. If you want to create a file, you use touch note. Then I check it out with ls again. And as you can see, we have our file named note. What this does is create an empty file. No content, just the file itself. A small detail here, people sometimes expect it to write something, but it won't. It just creates the placeholder. For folders, it's mkdir. Let's try out the command we can see in the material. Same idea, just for directories. Let's use ls one more time to check it out. Now, deleting things is where you need to be a bit more careful. rm note. As you can see, it removed our precocious note file. A sad day for us. It is that easy, right? But when it comes to directories, you need rm-r folder name. That R means recursive. It tells the system to remove everything inside that folder as well. And here's the important part. There's no recycle bin. Once it's gone, it's gone. That's a mistake people only make once. So let me explain more in depth about this R flag in our command. Usually when we are talking about directories, it means there should be stuffs inside of it. So a simple rm command is not enough. And the system basically being careful does not let us do it. But with the -r flag, we basically tell the system, okay, buddy, I know it is a directory and I know what I am doing. I want to delete it. And as you can see, with the -r, we successfully deleted it. Moving and copying stuffs. Copying uses CP, then source, then destination. This creates a duplicate, so your original stays intact and you get a new file with the same content. Let's create our note file so we can copy it, since we deleted it like my ex-girlfriend, My Will to Live. Alright, seems that our note file is up and running. Let's add some text to it, which we learned in our part 1, so we can see if the copying was a success. So remember, we need the source, which is our note file, and the destination. Let's check with ls if the copying was successful, and then use the cat command, also from our part 1 room, to check if the contents of it are the same, and it is indeed the same. Move command. It is similar to the copy command, but instead of copying, it modifies the second file, what we give to it. So MV doesn't just move files, it also renames them. So if the destination is just a different name in the same directory, you've effectively renamed the file. Same command, different use. That dual behavior is something worth remembering because it shows up a lot. Okay, it sounds confusing at first, but let's practice it to make it more clear. So about renaming. Let's use ls. As you can see, we have our note file. Now use the mv command on note and give it the IMoved name. Then use ls again. As you can see, note is no more, and we have IMoved instead. We basically just renamed it. Now let's check its content. As you can remember, we added the text hi into our note file, and as you can see, its content is indeed still hi, so we moved note to IMoved successfully. Now, one subtle trap in Linux is assuming what a file is based on its name. Just because something ends in .txt doesn't guarantee it's actually a text file. And sometimes files don't even have extensions at all. That's where we can use the file command. Alright, let's try it out. Let me make a new file named new. Now check out what the file command gives us about it. As you can see, it gives us the empty message. Of course, since it doesn't have anything. Now let's add some value to our new file. And then check it out again with the file command. As you can see, it is text because we gave text in it. This becomes really important in security scenarios. You might find something that looks harmless, but turns out to be something completely different underneath. So at this point, you're not just navigating anymore. You're creating, modifying, moving, and verifying. And that shift from passive to active interaction is exactly what enables the next layer. Understanding who is actually allowed to do all of this on a system. But first, let's check out the questions. How would you create the file named new note? We practiced it a lot, so it should be easy for you. It is touch new note. On the deployable machine, what is the file type of unknown1 in TryHackMe's home directory? So to solve this, just use ls, and we can see the unknown file. Let's use our newly learned file command and check it out. We can see that it is ASCII text, or I do not know how to pronounce. How would we move the file myfile to the directory myfolder? So as you can remember, we use the mv command, then the first argument is what we want to move, it is myfile, and the second is the destination, so to myfolder. So let me just show you this one, because we only did the same directory renaming method with mv. So let's type mv myfile myfolder. Then check if it is moved with the command ls. And as you can see, my file is gone. Now let's go to my folder and check out with ls if it moved successfully. And it seems it is. Now let's check its content with the cat command. And we got our flag for the next question, which is this one. So let's just copy it there, and we are done with task 4. Let's go to task 5, permissions. At this point, you can move around the system and manipulate files, but there's a big question behind all of that. Are you actually allowed to? Because in Linux, just because something exists doesn't mean you can access it. That's where permissions come in. If you run something like ls-l, you'll notice the output suddenly gets a lot more detailed, and the first part of each line looks a bit cryptic at first. Something like this. Now, instead of trying to memorize that pattern, break it into 3 groups. The first dash tells you what kind of file it is. So if it is a dash there, it just means it is a regular file. As you can see, we have one with the D, and that stands for directory. What else would it be for? Because as you can see, it is a directory named myfolder. The first set is for the owner. The second is for the group. The third is for everyone else. Each group has 3 possible permissions: read, write, execute. So when you see something like rw-, it means read and write are allowed, but not execute. This matters more than it looks. For example, if a file isn't executable, you can't run it, even if it's clearly a script. Or if you don't have read permission, you won't be able to open it at all. And in real environments, misconfigured permissions are one of the easiest ways systems get exposed. Now, there's another way to represent these permissions, numerically. Each permission has a value. Read equals 4. Write equals 2. Execute equals 1. So if a user has all 3, that's 4 plus 2 plus 1 equals 7. So if someone says a file has 775 permissions, it means the owner has all the permissions, the group has all the permissions, and everyone else has read and execute permissions. It is explained pretty good there, so I suggest you to read through it if you don't get it already. Instead of reading symbols, you're assigning values. Faster, but you need to understand what those numbers mean. Now, permissions are tied to users and groups. Even if a file belongs to one user, other users might still have access, depending on how those permissions are set. That's where switching users becomes useful, as we can see in the material you can use. su user2 to switch to user2 from your current user, assuming you know the password. The material also talks about su-l user2. You can look up the suman command to get more information about this. Here's a short summary of what this means. Right now, we are logged in as the try-hack-me user, and we're inside directory X. If we switch users using su user2, we will still remain in directory X, which belongs to the try-hack-me user. Let's say it's home directory. If we use su-l user2, we won't stay in directory X. Instead, we'll be taken to user2's home directory, directory Y. So now, you're not just interacting with files, you're understanding who owns them, who can access them, and how identity changes what you're allowed to do. And that's a key concept, because in security, access is everything. Let's check out the questions. On the deployable machine, who is the owner of important? Let's use the ls-l command here, and as you can see, it is user2. What would the command be to switch to the user user2? Well, it is su user2. Friendly reminder there, it usually asks for a password, the same way we connected to the machine at the beginning of the room with SSH. And then it asks us to change to that user. So let's just do that. The password for it is user2. The next question asks us to output the contents of important. What is the flag? So let's just use the good old cat command to check it. And as you can see, it is su user2. Now for task 6, common directories. Now that you can move around the file system and understand permissions, the next step is knowing where things actually live. Because in Linux, certain directories aren't random. They have very specific purposes. And once you know that, finding useful information becomes much faster. Let's start with etc. This is one of the most important directories on the system. It stores configuration files, basically the settings that control how the system and its services behave. You'll find things like user account information, permission configurations, service settings. For example, files related to users and authentication live here. That alone makes /etc a high-value location during investigations or enumeration. It is okay if you do not understand much at this task at the moment. Memorize as much as you can. We're going to visit and talk about these directories a lot, so do not worry about it too much yet. Let me just go back in the file system where these directories can be found. Okay, now that we are there, let me just give you a quick presentation how the etc directory looks like. As you can see, there are a lot of important stuffs, but for now, the most important ones are the things what the material shows you there. Now /var, this is where variable data goes, things that change constantly. Logs are the big one. If something happens on a system, login attempts, service activity, errors, chances are it ends up in /var/log. And this is extremely useful in real scenarios. Whether you're troubleshooting or investigating suspicious activity, logs are often the first place you look. Then there's /root. This one is simple but slightly misleading. You might expect the root user's files to be somewhere like /home/root, but that's not how it works. The root user has its own dedicated home directory, /root. And since root has the highest level of access, anything stored here is usually sensitive or important. We can't really check it as you see, as we switch to user2, and user2 doesn't have permission for it. Finally, /tmp. This directory is a bit chaotic. It's used for temporary files, and more importantly, almost anyone can write to it by default. That makes it useful, but also risky. From a practical perspective, it's a convenient place to drop scripts, tools, or temporary data. But from a security perspective, it's also a place attackers love to use because they usually have write access there. Another key detail, /tmp gets cleared regularly, especially after a reboot. So nothing there is meant to be permanent. So instead of seeing the file system as just folders, start thinking of it as a map. /etc for configuration, /var for activity and logs, /root for privileged user data, /tmp for temporary writable space. Once you internalize that, navigating a system stops being guesswork and starts becoming intentional, which is exactly what you need when you're looking for something specific. Let's see the questions for this one. What is the directory path that would we expect logs to be stored in? As you can see in our previous example, it is stored here, under the var directory. So it is /var/log. What root directory is similar to how RAM on a computer works? It is /temp as it is erased after every reboot, for example. Name the home directory of the root user. It is root, of course. Pretty easy one. Now apply your learning and navigate through these directories on the deployed Linux machine. So please, feel free to jump around. Maybe switch your user back to try hack me with the su command, and try to access the root directory, to which we didn't have permission with user 2. At this point, you're actually interacting with it the way it's used in real environments. You've connected remotely, started modifying commands with flags, handled files properly, and touched on permissions, which is where things start getting security relevant. Don't just move on immediately. Stay in the room for a bit. Play around, break things, try commands, move files, check permissions. Linux is really important, King, so don't be a normie, you know? The more you mess with it now, the more natural everything will feel later when things get less guided and a lot more real. I have a video on part 3 too, so check it out too with me. It is going to be fun. Date bio.